Good morning, ma'am. My name is P. Lakshman of Electrical and Electronics branch. My roll number is 20955802212. Today's subject is utilization of electrical power. My topic is loss involved in illumination. First of all, we have to know about what are loss involves in law of illumination. Illumination is directly proportional to the luminance intensity of the surface. That is the first law. And second one is inverse square law. The illumination of a surface receiving its flux from a point source is inversely proportional to the square times of the distance between the surface and the source. And two important laws of illumination, they are inverse square law and Lambert's cosine law. And first of all, inverse square law. The illumination of a surface is inversely proportional to the square of distance between surface and light surface, provided the distance between surfaces. The source is significantly large so that the source can be regarded as a point source. This is known as inverse square law. And E is illumination. E is directly inversely proportional to the square times of the distance. And if a source of a light when emits the light equally in all directions be placed at the center of the halo spherical, and the light will be falls in uniformly on the inner surface of the sphere. That is to say, each square of the surface will be receive the same amount of light. If the sphere will be replaced by one of the large radius, the same total amount of light is spread over the large area proportional to the square of the radius. The amount which falls upon the any square of a such a surface will therefore diminish as the radius increases, and we will inverse proportional to the square time of the distance. A similar relation hold if we held to deal with a beam of light in the form of cone or pyramid. If we consider parallel surface which cut the pyramid at different distance from the source, the area of the surface are proportional to the square of the distance, and therefore the amount of light which falls on one unit of the area those surface is inversely proportional to the square of the distance of the source. This relationship is referred as laws of inverse square law. And this is the inverse square law. We have the light source, and we have emitted the light, and which is d1 distance d1 and d2 and d3 are the distance in different areas. And next one is the Lambert's cosine law. According this law illumination varies directly as the cosine of the angle between the normal to the surface and the direction of the incident light. Illumination is directly proportional to the cos theta. And uh, first first law is the equation is inverse illumination is inversely proportional square times of the distance, inversely proportional to the square times of distance. And E is directly inversely proportional to the square times of distance and directly proportional to the cos theta. Therefore E is equals to I by d square cos theta, where I is the luminous intensity of the surface in candela units. Therefore H is the d into cos theta, or d is equals to h by cos theta, where a is equals to s square I by h square cos cube theta. When the source is sun and when the light is the source is falls on the earth, the angle between that is theta and the distance is d and height of the source to ground is h. And coming to illumination, I omega area a1 and lumens unit area is a1 is equals to omega into r1. Illumination of the surface area a1 is E is equals to I omega and omega r square I is equals to I by radius r1 square luminance per unit area. Similarly, illumination on the surface of area 2 is A2 is E2 is equals to I omega by A2. I omega by area is equals to omega r2 square is equals to I by r2 square luminance per unit area. Hence, the illumination of the surface is inversely proportional to the square of the distance between the surfaces. The light source provided that the distance between the surface and the source is significantly large, so that the source can be regarded at the point of source. And this is the inverse Lambert's cosine law, where we have picture lambda and the illumination decreases in the ratio cos theta by 1 and AB by AC is equals to 1 by cos theta. The expression for the illumination then becomes the E is equals to I cos theta by R square. S is the source and the B and C is the uh, place which are illuminated the light. According to this law, the illumination is at any point on a surface is directly proportional to the cosine of the angle between the normal at the point and the direction of the luminous flux. Thank you.